Across the void of space, the other planets orbiting our Sun have unique environments. All are different and hostile to life as we know it. Since the advent of robotic space probes, we have understood more about these planets and the moons that orbit them than we had learnt during all previous human history. At fantastic distances are the galaxies. It takes slightly more than 4 years for light to reach us from Proxima Centauri, our nearest star. But this is deep space. Our own planetary system orbits the Sun, a small yellow star that holds more than 99% of the solar system's mass. Its extreme gravity fuses hydrogen atoms into helium, releasing vast amounts of energy in the process. It is this energy that fuels almost all life on Earth. Our nearest neighbour is the Moon. It orbits the Earth at an average distance of 385,000 kilometres. It is the only celestial body that has had visitors from Earth. There were 6 manned missions to the Moon, and no one has been there since. But robotic probes are still being sent to gather data about the Moon. The European Space Agency's Smart 1 recently completed a mission to the Moon. It was equipped with a new solar-powered ion thruster and a new generation of remote sensing equipment. A new laser deep space communication system was used to direct the probe's cameras. Its X-ray spectrometer was used to compile a map of the Moon's mineral composition. Smart 1 is part of ESA's new effort with smaller, more advanced, yet cheaper exploratory probes. Venus is our nearest planetary neighbour, and it has also been recently visited by one of ESA's new generation probes. Similar in size to the Earth, Venus is shrouded in a dense, cloudy atmosphere. Engineers at ESA modified the design they had used for the Mars Express orbiter. Known as Venus Express, it was launched on a Russian booster, the Soyuz Fregat, from the Baikonur Cosmodrome in Kazakhstan. This launcher was introduced in 1966 and has proven itself as a low-cost, reliable rocket with around 1,700 launches to its credit. The Fregat upper stage was introduced in the 1990s specifically to boost commercial communications satellites into geosynchronous orbit, but its reliability was attractive to ESA, who used it to successfully launch their Mars Express probe. The Soyuz booster is assembled and transported horizontally and only raised to the vertical position on the launch pad. This helps keep production costs down. When space shuttle flights were suspended after the loss of Columbia, the Soyuz booster was the only way of sending crews to the International Space Station. Cooperation between ESA and the Russian rocket industry continues to develop, with the Soyuz booster soon to be launched from ESA's facility in French Guiana. The Soyuz launcher has a unique launch gantry that raises the rocket to a vertical position about 18 hours before launch, and also protects it from the buffeting winds that often blow across Kazakhstan. The Venus Express, sitting on top of the Fregat upper stage, had to be capable of withstanding the higher temperatures and radiation it would encounter while orbiting Venus, and it had to carry a greater fuel load, as Venus's gravitation is greater than that of Mars, where the spacecraft was originally designed to function. After a brief wait in low Earth orbit, the probe headed for Venus. The mission is controlled via ESA's network of tracking stations, including the new Deep Space Ground Station at Cebreros, near Madrid in Spain. The agency's Space Operations Center in Darmstadt, Germany, monitors Venus Express's system and signal flows, and the Venus team were jubilant when the craft successfully went into orbit around Venus. The Venus orbital injection maneuver had to be performed automatically by the craft's internal computer. It required the firing of the probe's main engine for a period of around 1 hour. Initially, Venus Express went into a 9-day orbit, but after 7 further orbital adjustments, the probe achieved its operational orbit. Information about Venus started to flow into Mission Control. Venus Express is studying the Venusian atmosphere and clouds in detail, the plasma environment and the surface characteristics of the planet. Earlier Venus missions suggested that the planet is geologically very active. It appears that some form of volcanic process completely resurfaced the planet around 500 million years ago. What makes the study of Venus difficult is the planet's extremely thick atmosphere. An abundance of sulfuric acid and sulfur dioxide suggests the presence of volcanic activity. In 1977, the 2 Voyager probes were launched. The craft would take advantage of a planetary alignment that would enable a single spacecraft to pass by each of the giant planets in our outer solar system. Almost 2 years after launch, the Voyagers approached Jupiter, and the support team at NASA's JPL were aghast at the complexity of the largest planet's atmosphere. Jupiter's outer atmosphere is divided into bands that rotate at different speeds. The edges of these bands are very turbulent, with what appear to be giant storms. Jupiter is more than twice as heavy as all the other planets combined. It is composed mainly of hydrogen, which is under so much pressure at its deeper levels that it is a metallic liquid. Jupiter's cloud belts are made from ammonia crystals and possibly ammonium hydrosulfide. The colours of these bands are seen to vary from year to year, possibly due to the upwelling of compounds that change colour under the influence of ultraviolet from the sun. The Great Red Spot is a storm bigger than the Earth. It rotates once every 6 days, and we know it is not connected to anything deeper in Jupiter as it travels around the planet with the upper atmosphere. Wind speeds of 360 kilometers per hour are common in Jupiter's atmosphere. The Voyagers detected a faint set of rings around Jupiter. They are made from dust that appeared to be ejected from some of the planet's 63 moons. This computer animation shows an oblique view of the ring system as seen from the surface of Ganymede, as it orbits Jupiter every 7 days. Jupiter's 4 inner moons are known as the Galilean moons, as they were first seen by Galileo around 1610. The moons of Jupiter were presumed to be dead and featureless, but they surprised everybody. Callisto is the second largest of Jupiter's inner 4 moons, and with a diameter of 4,820 kilometers, it is the 3rd largest moon in the solar system. It is made of rock and ice, and its surface shows some of the heaviest cratering patterns of any satellite in the solar system. Europa is covered by ice, but its proximity to Jupiter means that gravitational squeezing causes its centre to be warm, with an ocean beneath its icy surface. Researchers were astounded by Io. It orbits closest to Jupiter, and the gravitational squeezing that warms the waters of Europa cause Io to bubble with volcanic activity. Amalthea is a small moon with a regular shape. Late in 1980, the Voyagers were approaching Saturn, the solar system's 2nd largest planet. Though Saturn has only a slightly smaller diameter than Jupiter, it is less than 1/3 the mass of its giant neighbour. Like Jupiter, it has atmospheric bands that rotate at different rates, but the winds above Saturn blow at speeds as great as 1,800 kilometers per hour. Saturn's most prominent feature is its system of rings. The Voyagers found new features called spokes, dark areas which rotate with the planet's magnetosphere. These are not understood. At Saturn, the Voyagers would split up, with Voyager 1 on course to capture images of the moon Titan, and Voyager 2 continuing on to the outer planets. The two probes were performing perfectly, and their mission has been described as the most scientifically rewarding ever undertaken. Because they had to perform at such great distances from the Sun, the Voyager craft were powered by radioisotope thermoelectric generators, fueled by plutonium-238. These will keep producing power till at least 2020. Voyager 1 showed that Saturn's F ring was actually 3 narrow rings that appeared to twist in a complex pattern. Voyager 2, on a slightly slower path, reached Saturn 9 months after Voyager 1. It was instructed to look more closely at the rings. The average thickness of the rings is around 20 metres, and they are mostly crystals of ice. Voyager 2's photopolarimeter was aligned to measure variations in the light from the star Delta Scorpii as it passed behind Saturn's rings. It revealed that there were very few open gaps between the rings. An instrument known as the Infrared Interferometer Spectrometer was focused on the moon Tethys. It would measure changes in the moon's surface temperature as it moved into Saturn's shadow. Voyager 2 had to pass behind Saturn to receive a gravity-assisted boost that would send it on a new path toward Uranus. As it passed behind the giant planet, Voyager 2 lost radio contact with Earth and mission control back at JPL. As it entered Saturn's shadow, the probe dropped below the equator near the faint G ring. Like the other giant planets, Saturn rotates on its axis very rapidly, taking about 10 hours to revolve once. This causes a flattening at the poles. From a distance of about 94,000 kilometres, Voyager 2 recorded a series of images of the surface of the moon Tethys, revealing an impact crater almost half the diameter of the moon. As Voyager 2 emerged from the shadow of Saturn, it realigned its high-gain antenna to point at Earth, and communications were re-established. From time to time, the probe carries out a rotational manoeuvre to determine its own magnetic field. It must do this so that its magnetometer can correct for local disturbances when measuring the magnetic field through which it is travelling. Voyager 2 was now headed to Uranus, and Voyager 1, before it headed above the plane of the planet's orbits, focused on the moon Titan. Its surface cannot be seen through its greenish, nitrogen-rich atmosphere. Rhea is the next largest of the Saturnian satellites, and Dione is accompanied by its own submoon Helena. Like Rhea, it has a bright leading face, while its trailing hemisphere is much darker. Tethys is similar in size to Dione, and Enceladus, with a diameter of just 502 kilometres, shows a regularly cratered face. It orbits very close to Saturn, as does its similarly sized companion Mimas, with a diameter of 394 kilometres and a far older, lumpy surface. Hyperion is considered to be the remnant of an ancient collision. In 2004, another probe visited Saturn. The Cassini-Huygens probe went into orbit around the giant planet and remains there to this day. This was to be a two-part mission, with the Huygens landing craft set to put down on the surface of the moon Titan. The probe had followed a complex path to Saturn, travelling first to Venus, where it received a gravity assist, then back past Earth and Jupiter. It took 7 years to reach Saturn. When it arrived, the craft flew through a gap between Saturn's F and G rings and became the first probe ever to go into orbit around Saturn. A series of orbits was tailored to allow Cassini to measure the range of particle sizes within the ring system. After 6 months in orbit, the focus shifted to Titan. In late 2004, Cassini released its Huygens lander. 3 weeks later, Huygens successfully entered Titan's thick atmosphere and parachuted to the surface, and it began sending pictures to Cassini for relay back to Earth. They revealed a pattern of erosion due to fluid that scientists speculated could have been liquid methane. It is a soft-looking terrain with no evidence of craters. The atmosphere is rich in complex hydrocarbons, the type of chemistry that researchers recognise as the precursor of life on our own planet. At the surface, the cameras recorded a weathered landscape with rounded rocks like river stones. But soon the lander's batteries were depleted and the craft became silent. A total of 350 pictures were relayed from the Huygens lander back to Earth. In early 1986, Voyager 2 reached Uranus, which has rings and spins on an east-west axis. It is the solar system's third largest planet. Uranus's cloudy surface was featureless, and the Voyager imaging team again focused on the planet's moons. Oberon is Uranus's outermost and second largest satellite. Its surface is dominated by relatively large craters and has what appear to be fault lines. Titania is the planet's largest moon. Like Oberon, it shows craters and fault lines, but it also has smooth areas that appear to have been resurfaced. Miranda has fault lines stretching across its whole face, suggesting it was shattered and then reformed. In 1989, Voyager 2 reached Neptune, the last great planet near the end of the planetary disk. Neptune is so far from the Sun, it takes 165 years to complete one orbit. It has a clouded atmosphere, and Voyager 2 was able to determine that the Neptunian winds were blowing at an incredible 2,000 kilometers per hour. Like Earth, Neptune spins east to west, but the winds at the equator blow in the opposite direction. In the southern hemisphere, there are two features that resemble Jupiter's red spot. Two storms as large as the Earth spin in a counterclockwise direction. Neptune has 8 moons, the largest of which is Triton, which is similar in size to our own moon. Unlike any other moon in the solar system, Triton orbits in the opposite direction to the rotation of its mother planet. This suggests that Triton was not created at Neptune and that it was captured. Triton's surface appears to be made of frozen nitrogen and methane. Mission specialists were stunned when they realized that the moon had erupting geysers, pushing material to a height of 8 kilometers. As Voyager 2 headed away from Neptune, the planet had one last surprise. Cameras captured the faint remnants of a ring system, only apparent when backlit by the sun. 2 narrow rings, and a third, which is more diffuse, all appear to be composed of fine dust. A 4th ring forms a broader sheet. Both Voyager probes continue to travel away from the Sun and are still in contact with Earth. Recently, Pluto was demoted from its planetary status, being declared too small to really be a planet. But that happened after NASA had built and launched the ambitious New Horizons probe. It was designed to observe Pluto and its primary moon Charon, and then to proceed on into the Kuiper belt. Last year, it flew past Jupiter and carried out more detailed observations of the giant planet's atmosphere. Travelling around Jupiter also gave the probe a gravitational boost on its journey to the edge of the solar system. The trip to Pluto will take more than 9 years. New Horizons weighs around 450 kilograms and is the size of a grand piano. observations of Pluto will start about 6 months before closest approach. This will help detect any unknown moons or other objects that may need to be avoided or singled out as new targets. The probe will relay high-resolution images of Pluto and Charon back to Earth, as well as information about surface minerals and atmospheric composition. These images are largely speculative, as the only images of Pluto and Charon are of extremely poor quality. Beyond Pluto is the mysterious Kuiper Belt, which presents the probe with an interesting set of problems. Precise orbits of Kuiper Belt objects are not certain, and controllers are keen to conserve fuel for unplanned course corrections. To find out what lies at interstellar distances, a research team working high in Chile's Atacama Desert is using a new technique to detect planets in orbit around other stars. In the constellation Sagittarius, close to the centre of the Milky Way, the astronomers have discovered a world about 5 times the size of the Earth. The discovery suggests that such small rocky or icy planets may be more common in the cosmos than Jupiter-sized gas giant planets. It also indicates the power of a relatively new method of finding such exoplanets. The technique, known as gravitational microlensing, measures the change in a star's intensity as a planet passes between it and the observatory on Earth. The new planet is the third to be uncovered by the technique, which registers a temporary but telltale boost to the brightness of the more distant star. This is an effect predicted by Einstein's theory of relativity, and it holds out the possibility of finding relatively small planets with masses and orbits similar to the Earth. Researchers say the planet appears to be much too cold to sustain life, probably reaching no more than -220 degrees Celsius. In the centre of our own galaxy, the newly discovered planet rejoices in the catchy name OGLE 2005 BLG 390 LB.